Testing, testing, testing. Testing, testing.
Hello? All right. How are we doing, guys? We ready for the meeting today? Yeah. We got a good presentation for us. All right. Make sure you guys join the Discord if you have not. Also, make sure you guys sign in. 3 sign-ins to be confirmed a member. And also for elections, if you want to run, you also have to be a member. So make sure you have 3 sign-ins. Also sign in for pizza later today at 2. All right, make sure you guys check the calendar to see any events that we have coming up at the end of the semester, or to see any interest groups or any meetings that you want to be a part of. Also, make sure you guys join the RITSEC mailing list as well to see common updates about what we're presenting on and what's happening in terms of RITSEC. Make sure you guys follow our social media as well. We got some cool posts going out there on LinkedIn, especially for ISTS. Also, check out our YouTube if you want to watch any presentations, and also check out the Instagram. Now, guys, clap it up for the sponsors. Thank you. All right, time for announcements. We have the WESIS Cross Chapter CTF. It's an online CTF happening on March 28th, which I think is next weekend. If you guys are interested in joining, scan this QR code. It is Easter and St. Patrick's Day theme, I'm pretty sure. So, yeah, make sure you guys sign up for that if you want to get some CTF experience down. Also, there's a WESIS movie night happening as well on March 28th. It's from 11:30 to 2:30 at the Marshall. If you guys want to watch Snowden, cool cybersecurity movie, right? Scan this QR code and make sure you guys sign up. Cool social event. All right. We also have a WESIS ice skating event. The WESIS ice skating event this year will be happening at Tim Hortons Iceplex from March 21st from 1:30 to 3:30. If you guys want to carpool or meet up beforehand, meet in the GCI lobby at 1:15. Also, this QR code is the sign-up information too. So if you're interested in going ice skating, scan this QR code. It is free, and I'm pretty sure if you want to rent skates, that is also free. You just before you actually enter the area to rent skates, the e-board of leases has to be there first to sign in. So either get to the ice rink at 1:30 or meet at 1:15 at the GCI lobby. Check out WESIS channel for more information as well. We also have election nominees. If you want to nominate someone to be one of the positions, we have president, vice president, director of PR, secretary, the competition architects, education, and research for nominations at the end of the semester. If you want to nominate someone, scan this QR code and fill out the information there. The nominations go until the 31st at 8 p.m. And then we will reach out to candidates that are nominated to see if they want to compete for that position. And then we will have the elections during April 10th and April 17th during the general meeting, and the candidates will be announced on April 8th. All right, guys. Make sure you sign up, even if you're a freshman. If you guys are interested in being education or research, could be a cool position for you guys to do. Don't be afraid to reach out to me or Hayden if you guys are interested in any of the general meeting roles. And now we have Intro to Vulnerability Research by James Gill. All right, so this is the mic we have today.
Oh.
Yeah. All right. Oh.
Oh dear. Cool. All right. Where's the?
This one. So you
All right. And do I need to be standing in front of? Where's the camera?
set the camera. You can see yourself right there.
Cool.
So yeah, you might want to just stand here, but it's okay.
Yeah. All right. So this is going to be introduction to vulnerability research, sort of just like in general. First, I guess I'll introduce myself since not everyone here probably knows me. I'm James Gill. Software engineering major, actually, not cybersecurity. I've worked for a company called Beeper for several years now. And reverse engineering is like my hobby and like basically what I do for work as well. Found several CVEs in iOS, do a lot of iOS research. iMessage protocol is a lot of what I've done in the past. And I'm from Bethlehem, Pennsylvania. So I guess that's quick about me, just in case you don't know me. Sort of today, I guess I sort of had it split up into a couple parts. First, I was just going to go over in general, what is vulnerability research, why I do vulnerability research, why it's really interesting to me. Sort of modeling, both threat modeling and creating a mental model when you're doing vulnerability research. Sort of some ways to get into vulnerability research with end-day research and identifying different attack surfaces on systems. And also I was going to add some slides about AI usage since that was sort of a recent development that's been really changing how vulnerability research is approached. Higher? Okay. I can't tell how sensitive this mic is. Yeah. So I guess I was just going to start sort of with this definition of vulnerability research, right? Vulnerability research is analysis to discover sort of unexpected behaviors that may exist in equipment or services. And I say unexpected behaviors come in many forms, right? And that may be like explicitly like memory corruption or something like that, but it may just be like a logic vulnerability, something doesn't sort of behave in the way that you expect, behave in the way the person who engineered it expects, or in the way that other systems which interact with that system sort of expect, right? And we're sort of interested in researching what those behaviors are, why they occur, and how we can discover more of them, and to some extent how we can use them to our advantage. Why do vulnerability research? I don't know, these are just some different points. Despite the fact that it's boring and tedious, obviously you're sort of making software safer, right? I mean, that's what everyone says. You're gonna get vulnerabilities patched before they can be abused. And you can have like CTFs and competitions where you use those skills in sort of a competitive environment. One of the things as a software engineering major I think is always really interesting and useful is you're sort of learning from other people's mistakes. When you find vulnerabilities in other software, I think that's a really good and interesting way to find out what not to do in sort of your own software. More interesting to me than sort of just list of things not to do, a checklist or whatever, right? And also just like understanding how real systems function, right? A lot of these things are sort of opaque, and it's really fun to sort of look under the hood and understand and reason about sort of the underpinnings of the system. Also, obviously, there are bug bounties in careers, just because these vulnerabilities can have large bug bounties. I mean, I've gotten several bug bounties myself. And also, you're obviously going to get approached by, I mean, everyone in cybersecurity does, like government contractors and stuff like that. You also might get poached by the company you're attacking. I have a lot of friends who have been hired by Apple out of sort of Apple's security research. Like, it's kind of annoying how often it happens. And obviously, there's also the sort of aspect of jailbreaks and modifications. If you find vulnerabilities in, say, iOS, you can use those to modify your own device. But this also applies to sort of other systems. Android is locking things down now. You know, there are other things, cars. But sort of the place I always like to start when I'm sort of introducing vulnerability research is you got to sort of model what you're attacking and why, right? It's sort of very easy to get this wrong, and there are sort of different approaches that are going to be informed by sort of why you're attacking. If you're attacking a system that you have physical access to, say an iPhone, right, and you're trying to jailbreak it, you're going to have access to like different things than if you have to attack it entirely via sort of a web page or some kind of like remote access. But also, say desktop environments have sort of a very different threat model than mobile environments, right? If you have a desktop application that's running, you pretty much, other than sort of like antivirus, on Windows, it's pretty much can access all of your data. And so that's a very different threat model from, say, iOS or hopefully Android, in that you can run sort of an untrusted application and it shouldn't be able to get access to your entire photo library or whatever. Whereas maybe a Windows app, or it could just like enumerate your entire photos folder. And so sort of what vulnerabilities you're going to be looking for are going to be sort of impacted by that. This also is good to keep in mind when you're sort of looking at what other people consider vulnerabilities, especially recently with like AI and SLOP, things like that. There are a lot of people calling things vulnerabilities that aren't sort of relevant, like it doesn't really matter. Also, there's things like sort of Linux considers root to be the highest privilege level. If you run some malware as root on Linux, I mean, you've pretty much compromised the system. Ideally, if you run it on Mac OS, there are additional layers because Apple does not allow even things running as root to do all the things that Apple themselves can do. You know, Windows, I mean, it's just enforced with antivirus, which is, I don't know, that's the thing. So I guess sort of, I was going to put case studies throughout this presentation. Sort of one of the things that you often see, like, for example, this person on Twitter is telling people, don't install Signal for macOS, it's not secure, right? And they're saying they've written sort of a simple Python script that is able to copy out all of the messages that you've received in Signal, right? And looking at this at a first glance, you're going to think, like, this is a vulnerability, you know, maybe I shouldn't use Signal for macOS. But if you think about the threat model here, it starts to get a bit weird. And so you could argue it depends on how you look at it, right? From the macOS security model, running a Python script unsandboxed is kind of bad, and is bad enough that exfiltrating Signal chats is maybe not even your biggest or a huge concern, right? You might not know this, but apps that are running without a sandbox, at least right now, can actually bypass two-factor authentication on your Apple ID. This is just like an API that Apple provides. They don't document it, and I don't think you're supposed to use it, but it does exist. And so if they, for example, gave you a prompt, enter your username and password for your Apple ID, they'd be able to bypass two-factor authentication, make phishing all easier. Personally, that would be a bit more of a concern to me than the fact that they can like copy out my Signal chats. And I don't really think there's anything that Signal in particular can do to defend against this, because they're just a normal desktop application. And so that's sort of, when you're doing vulnerability research, you're sort of trying to keep in mind sort of what is the threat model, why is this vulnerability important, and yeah, that. Sort of once you've sort of identified sort of what the mental model or what the threat model is, I always like to start with creating a mental model of the system, right? Especially as a software engineer, this is really interesting to me, but I think that it's just in general really important to be able to sort of predict how a system is going to respond more than just testing a whole bunch of different things. Because if you can predict how a system is going to behave ahead of time, you can rule out sort of bad approaches. And when something doesn't behave how your mental model expects it does, that's often a good indicator of when something might be fishy or like there's potential for something to have gone wrong. Yeah. What else can I say about this? Yeah, I mean, obviously, once you have a mental model, you do need to test things, right? It isn't very useful to just think about a thing. You want to know where there are concrete vulnerabilities, but it would be really slow to test every single thing across a huge system, especially an operating system or something large like that. So you've sort of got to have a mental model of how the different pieces fit together, and you've just got to research until you have such a model, at least to some extent. One of the really cool things I think we do in sort of vulnerability research as sort of end day research, even if you, the problem sort of with starting from scratch with vulnerability research is you don't necessarily know a vulnerability is there. Obviously, all systems have vulnerabilities to some extent. So you know a vulnerability is probably there, but it might be a long time until you find it, and it might be, you might not find it. But with end-day research, you're pretty much guaranteed to have, you are guaranteed to have research. Something was patched. And often it's really interesting because there might not be a publicly available proof of concept. You might not be able to sort of exploit it normally. But you're sort of taking advantage of the fact that other people, people who maybe have more time than you, people who are nation-state actors, are looking for vulnerabilities too, and the vendors usually find out about them and patch them and issue CVEs. And you can sort of use that fact to exploit slightly out-of-date systems or research vulnerabilities in slightly out-of-date systems by looking at sort of what the patch does and what has changed. And this is practical. Because obviously it takes less time if you have sort of something to guide you, and it gives you good practice with these exploit techniques. Also, the patches may be incomplete. Often when vendors patch things, they don't maybe find everything, and maybe there's a related bug that you can find. And also, not every system is updated regularly. Like, a lot of systems are not updated regularly. For some good examples of end-day research, I don't know if anybody here has been paying attention to the iOS sort of scene recently, but literally in the last week there was this Corona exploit that Google Threat Intelligence sort of mentioned, and there's actually publicly available samples of that. And also literally yesterday there was the Dark Sword sort of exploit chain that they put out a thing about. Those are really interesting because even though the CVEs they were sort of already patched for the most part, though for the Dark Sword one that was yesterday, some of those weren't patched until iOS 26.1. Which, if you know anything about iOS release cadence, 26.1 wasn't that long ago, like at all. I think we're on 26.3 or 4 now. That was a couple versions ago. Corona was sort of targeting older devices for the most part. Apple actually put out a release for iOS 15, which they haven't done in years, specifically against this. But as of right now, that's sort of just an immediate, very interesting end-day research because you can sort of use these vulnerabilities and yeah, they're sort of publicly available to some extent. Another thing is that VRig has been doing. I know they've been doing Chromium bugs. There were a whole bunch of bugs in sort of V8 and the Chromium JavaScript engine that they were looking at. But basically the idea is that it's going to let you know where other people have done research and successfully found vulnerabilities. It might not be the easiest place to find new ones because obviously other people are looking at it. my approach has often been to find sort of my own niche. If you can find some forgotten or not well-known component, that's obviously gonna not have been researched as much, and it's probably gonna be a bit easier than maybe finding a vulnerability in some high-profile thing that just had a whole bunch of CVs in it. But yeah, I was just gonna focus more on those exploits that were discovered in the wild by Google Threat Intelligence. It was actually pretty funny. The Karuna one, I'm pretty sure it was delivered in plain text by a bunch of like crypto gambling scam sites, which is pretty funny. They were like burning like full like zero-day exchange on crypto scams. I'm pretty sure like the entire point of it, like they compromised your entire device just to steal your crypto wallet. So like that's pretty interesting. But the thing is, a lot of those sites were still up when this Google Threat Intelligence thing went out. So we actually have like publicly available samples of like the JavaScript code that did this exploit, like literally from a couple of weeks ago. And so that's really interesting sort of for end-day research, because you don't even have to do patch diffing or find out yourself. You just need to reverse engineer how the delivered exploit works. Though some people don't bother reverse engineering it, especially in the age of Claude Code. I think I saw some people on Twitter who took the actual live malware, modified it with Claude Code to inject like tweaks to like customize their iPhone, and ran it. Like live malware they did not fully understand against their own device for the purposes of customizing their device, which is pretty funny to me. But yeah, that's a thing, I guess. iOS has recently started introducing a lot of mitigations against native code execution, and you'll start to see in some of these end days like Corona that they're starting to use tricks like running everything in JavaScript to avoid doing native code execution. I'm pretty sure they just injected the JavaScript interpreter or had it loaded inside the processes that they were exploiting, rather than trying to get code execution. Sort of identifying where to attack, right? Or where to sort of to do research. There are basically two approaches that I've probably been sort of mentioning, right? You can strike where it's weak, where something hasn't been researched in a while, something that's really old, or you can strike where you sort of need it, where it's going to be impactful. Approach number two is what things like fuzzing are for, right? That's where you're looking at something because you want to find a vulnerability there. If you're looking for a vulnerability specifically in WebKit or V8, you've already identified sort of the component you're attacking, and you're doing it because you need some primitive, or you just need to attack that thing, right? On iOS, you need to have pointer authentication signing vulnerabilities to do basically most of the attacks. You're going to have to attack it. But that's often not the most fun and efficient. So approach one is to strike where it's weak. It's going to require lots of manual review, finding new places to attack. But you're looking basically for things that are old, things that are brittle, interactions between different things, especially if they were written by different people or different companies or people who didn't communicate well. Even within like iOS, you'll see that often things are siloed, people don't talk to each other all the time, and those boundaries are going to be weaker. Case study, I had a CV back in 2024. In fact, like there were like several that were all related about USB backup restoration. Basically, when you're using iTunes, you can restore backups of an iPhone. And if you think about restoring backups, one of the things it needs to do is read and write files anywhere on the system. But nobody really does USB backups anymore. And also, this feature has existed since like the initial version of iTunes. Apple has been pushing recently like iCloud backups, and those use a different system. And so it had been very utilized, under-researched, because this code was so old and had not been looked at recently. And so it was literally something as simple as putting ... as part of like the domain of like the file you were restoring. It was not sanitized at all, and you could just write files anywhere. And because it was backups, it was given permission to write anywhere on disk as root on an iPhone. And while that may not be sort of the most, you can't get code execution from that, but you can use that to easily pivot to other parts of the system that maybe you're not expecting their internal configuration files and stuff to be overwritten. In fact, you could chain that with a vulnerability that was already known on iOS 17.0, a code signing vulnerability, and you could use that to run arbitrary code with arbitrary entitlements, or basically like high permission levels that only system apps would normally have. And there was like, after Apple patched it and gave a CV, there was a follow-up vulnerability that I found, which was you could put symlinks in your backup, and it would follow the symlinks when it was writing out the files. It was really quite silly how simple that was. But when you find sort of niche places that haven't been investigated, you're often going to find vulnerabilities like this. When you're identifying where to attack, if you first don't succeed, often you can just try many things. Modern systems are sort of like a complex tower of blocks, right? Everybody knows this XKCD, right? Where you have like a tower of blocks. And while this is sort of, you could say this is digital infrastructure, this is also like like any digital system, pretty much, sort of can be viewed like this. There are going to be random weak points that for some reason are holding up the whole system or have a lot of impact, but nobody really knows about them. Especially with operating systems, like all modern operating systems are derived from older operating systems which have been written in like, the 1900s to say, like they're decades old and maybe they haven't been reinvestigated. Oh yeah, it's like a Jenga tower, right? A lot of people, when they're talking about sort of vulnerability research, might say it's sort of like it's all C's fault, right? You have memory corruption, you have buffer overflows, use after free. These are all vulnerabilities that arise due to programming in C most of the time, or in languages like C, doing things by hand. There are very few guardrails, which relies on humans not making mistakes. And pretty much the general rule of things is humans always make mistakes. Like, they always make mistakes. It's not possible for them to program things perfectly. So if there aren't sort of strong guardrails, then there are going to be vulnerabilities. And so then you have, as a reaction to this, stronger languages like Rust and Swift and all these modern things that sort of try and eliminate classes of bugs like that. But there are other classes of bugs, and if you're doing vulnerability research, these are often going to be very interesting, right? These are going to be like logic vulnerabilities, JIT vulnerabilities, hardware vulnerabilities. Anything to do with concurrency is always very hard. Specifically with JIT vulnerabilities, you'll notice things like the JavaScript engine. When JavaScript wants to go fast, they have to compile things to machine code sort of at runtime. And even if, which it's not, that JIT compiler is probably written in C, but even if it was written in Rust or something like that, it's going to need to output raw sort of machine code. And so if you can convince the JIT compiler to get into a bad state logically, you're going to be able to emit arbitrary machine code. So it's sort of an interesting target, even if you don't have the same classes of memory vulnerabilities. Also, when you're attacking sort of an operating system, it has a lot of security properties that it has to enforce with logic. On iOS, you have things like permissions and entitlements, but every system has this. Is a program allowed to do something? You've sort of got to enforce that with logic. So even if there isn't a memory corruption vulnerability, there are quite probably sort of people did it incorrectly logic vulnerabilities. You've also got hardware vulnerabilities, obviously. Stuff like they did something incorrectly in the low-level bootloader, stuff they can't patch. Side channels, stuff like that. Yeah. Yeah, so that's probably what I was going to say on that. Another topic, I guess, that sort of I added here was that AI for vulnerability research is sort of becoming more useful. Large language models are advancing by the day, and they're really good at recognizing sort of patterns, right? They're not very good at reasoning, but they're good at recognizing patterns. And a lot of vulnerability research is actually recognizing patterns. Because obviously a lot of these vulnerabilities are going to be very similar, and how a system works is going to be sort of similar to how another system works. It's sort of useful to have this pattern recognition. And also, if you give it like a decompiled function, sometimes it's really good at sort of giving you sort of a high-level overview of like several functions so you can quickly review them. But there are some drawbacks. Because they're not very good at reasoning, you often need to have them directed somehow. And so there are two main sort of approaches that I've seen so far, and that's sort of automated testing harnesses. If you can get sort of a large language model into some kind of a feedback loop, then usually after a lot of iterations, it can do something useful, right? That's how like a lot of those like Claude Code type things, even for like regular software engineering, work, right? You give it some unit tests, you tell it, keep doing things until this passes, and it starts doing like sort of almost random things. It's not very good at reasoning why it's doing things, but eventually it'll get there usually. And sort of the other way is to just have a human doing that direction and using sort of a large language model only as a tool for analysis. One of the really funny things I've seen is that clearly in the wild, exploits are actually starting to be at least modified by AI, if not developed with their involvement, which is sort of lowering some of those barriers and making them cheaper. I'm wondering if this is sort of connected to like those recent, the Corona and the Dark Sword that we were seeing. People who have seen those, and I looked at some of the publicly available stuff, it looked like some of it was developed with like Claude Code or something, just from like the commenting style and the way it was written. So that's kind of like interesting. The fact that they were, like the person who found those vulnerabilities was presumably willing to give them to a person who is just going to deploy them with Claude Code. Yeah. All right. But yeah, so that's sort of large language models that they're sort of advancing, and you can use them, but they're not going to usually be able to sort of just one-shot a vulnerability. You're going to have some kind of reasoning in the loop. Yeah. I guess then I was going to sort of go over some sort of common tools and ways to do vulnerability research. If you're thinking about like the theory behind it now and you want to put this into practice, doing vulnerability research requires figuring out how the system works. I was talking about building a mental model. Obviously, if it's open source, something like the Linux kernel, even like the X and U kernel that underpins iOS is open source to some extent. Just read the source code. But if it's not, we sort of need a way to understand what the program is doing. And if you think about it, clearly a computer is able to understand how to run the program. The kernel on iOS obviously is run by like a chip, and the chip has to follow the instructions. So clearly those instructions exist somewhere. And so why can't we just read what it's doing? Traditionally, the answer is that like a compiled language like C is going to be compiled into like assembly and machine code, which are hard to reason about by a human. But now we have decompilers, which are sort of things that use heuristics and sort of an understanding of what the higher level structure associated with those machine codes instructions is going to be, and turn it into something mostly human readable. And then you can sort of maybe use AI or something to clean it up, or manual human review to sort of understand what something is doing. But common modern tools, decompilers for this are like Ghidra, IDA, and Binary Ninja. Just those three. IDA is like insanely expensive, unless you get like a cracked version of it or something. Ghidra is free, but it's like not the best oftentimes. in terms of its output, and it's kind of like annoying sometimes, but it's free, so you know that does have advantages. Personally, Binary Ninja has like a good student discount. I think it's like really cheap if you're a student, and the free version is also like acceptable for some things. So that's sort of what I use day to day, and that's sort of my favorite. Also, I was just going to mention this. Like, there's some things like Pone College that have some really good resources for sort of introductory things and advanced things. I was just going to sort of, if you haven't seen this before, give you sort of a general look at what something like Binary Ninja is going to be giving you when you open just like an executable binary, right? You're typically going to have sort of the decompiled function, and that's going to be either in some kind of something that looks like C or some kind of pseudocode. And obviously, in the start, it's maybe, depending on the binary, not the most useful because things have names like based on the registers. They're just going to be called like var 118. That's not going to tell you very much. But usually, rather than giving you sort of like a plain text editor, like a normal code editor will, they'll allow you to rename things while keeping it within this structure, because obviously it has to be within this structure to match what the binary is doing, but the names that are just for a human, those are changeable. And then it's going to give you some tools to like quickly find things, because obviously you don't want to just scroll through the program from beginning to end. So you're going to have things like strings, which are going to be any text that appears directly in the binary. Things like the functions. Usually, in most production binaries, you're not going to have names of like internal functions. You're only going to have names for things that are going to be like public API or like it's calling into an operating system library. Though that's really useful, but you're going to have a lot of things that are just like subroutine, like 55,000 or whatever. Usually it's memory address actually, but they're not going to be named until you name them. But to sort of help you find out what something is doing, it's going to give you sort of the cross references. I have those in blue. And that's going to be what functions call other functions. So you can use this both with the functions you don't know anything about, like the subroutines, but also you can use it with a particular operating system API function or library function that you already know about, figure out what's calling it, and sort of infer based on the function that's being called what it's doing. When you're using these tools, there's sort of different approaches. Obviously, doing straight binary reverse engineering like that is going to give you a definitive answer on how something functions, but it's going to be like kind of a lot of work. And by a lot of work, I mean you're going to have to like rename things a lot, and it's going to like be sort of tedious to go through every function. So sort of what I was talking about before with like the threat model and the mental model becomes really useful. You should narrow the scope of sort of what you're going to be reversing. This is both, this is like, depending on your approach, usually you're going to be doing something like analyzing like logs. Like most operating systems have some kind of logging facility that's going to be just spitting out stuff all the time. And often you can even do things to sort of increase the log level, give you more information. Because obviously, system developers are humans too, and they need to debug things. Usually they put in some kind of debug logs. If you can enable those, that's really helpful. And it's going to give you sort of a good picture of what the program is doing and where it's doing something interesting. If you can find a good log, oftentimes you can find it as a string, and you can go find where you need to decompile your code without looking through the whole function. Also, you're going to be comparing it to different but similar implementations of things. Despite the fact that, say, like Linux and the kernel behind macOS are different, they're going to be making a lot of similar design decisions. So you're going to want to sort of do some cross-referencing. And sort of, this is just something you sort of acquire. The more systems you look at, the quicker usually you can pick up on sort of these patterns. And that's just something that takes like a lot of looking at different systems. But going back to the AI stuff, AI is particularly good at recognizing patterns, so sometimes you can use that as sort of a shortcut. just to give you some things that look similar. For doing binary reverse engineering, sort of a case study I wanted to mention. Well, first of all, developers are quite lazy, usually, especially when you're not targeting a big product like Android and iOS. They're obviously going to be very heavily secured, or they should be at least. And so some of them, it's simply a matter of understanding how the system works, and you're going to find some low-hanging fruit. So I'm going to give like sort of an example from like a real LTE cellular base station I was reverse engineering. This is like the decompiled output. And depending on how much experience you have, you might look at this for like a couple seconds and say, oh no. Can anyone point out something about this that makes them go, oh no, sort of quickly? If not, I have a thing to highlight it. Oh, it's too small? Okay, well, that's unfortunate. Is a mouse show? Like somewhere in this area, if you can read. No. It's something very, very obvious and very bad. Okay, I'll just point it out. There's a call to system right here. And if anyone knows about like system, the call, if you've used like Python, you do os.system to run a shell command. They're running a shell command. And to give you some context, this is a program that accepts user input as an API. It's running as root with full permissions on a Linux system, and it's running a shell command. And then if you look closer, you see right above this shell command is vsn printf. And so you're starting to get worried because when you're doing printf, that means you're sort of concatenating a string. You're creating a string, and you're feeding that string into system. And why are you using vsn printf unless you're using sort of input that changes? And in this case, if you look over to this function is called command. In fact, I should actually just highlight this. This function is called command, and it's called over here in this larger function. And it runs command string bin/remove rf %s. So it's removing a file by calling system as root. And so if you think about that for a second, where does the name of that file come from? It comes from a file that you uploaded to the API. So you control that file name. So this means that you control a string that is being fed into the shell. And if you know anything about a bash shell, you can run multiple commands in a single line using semicolons. So what happens if we name our file semicolon like change password or some other command that we want to run? And in fact, it is that simple. This command is really, this file name is sort of really long because when you're doing file names, you can't use like slashes, obviously, or else it was parsing it out. But it's literally just a semicolon and then like a bunch of stuff to encode slashes. But it's essentially running sed on etc set shadow to change the root password. And you just upload a file with this really long string, and it changes the root password, and you can get a root shell. And so this vulnerability does not require any sort of memory corruption or like fancy techniques. It was literally just looking and seeing that immediately a call to system is probably bad, especially in something that's running as root and processing user input of some kind. And you see remove rs %s, well, this is clearly getting bad. And so that sort of vulnerability is often going to be there in sort of systems that are more niche or are not well researched, especially if they're older. To give you more context, essentially this is you're uploading a config file as a .zip using the CWMP management protocol, which is like this stupid management protocol that's used on a lot of like basically modems, you know, like ISP modems and stuff, but also cellular modems. It's a stupid curse protocol. Basically, it does HTTP requests, but they're inverted. The response is the request, and the request is the response. Stupid protocol, in my opinion. But curse things are usually vulnerable. And so basically, if the proper files were not deleted, it ran remove RF on the zip file that you uploaded. So if you named your zip file the aforementioned string, then you got a root shell. You know. So basically, when finding this vulnerability, the entire challenge was finding where to look, and not so much the sort of binary reverse engineering. Like this screenshot here, this was, I opened the file in Binary Ninja and did literally no renaming or analysis of things. Like, I clicked on cross references for system, and it showed up. So, you know, it's not always immensely time consuming or difficult if you know where to look and you sort of have an understanding that, like, the daemon that this is, the CWMP daemon, is doing configuration stuff, and, you know, it is processing user input and sort of stuff like that. Yeah. It's 12:54. Okay, so that's pretty good on time. I was just gonna mention real quick. Do I have slides after it? Yeah, I don't. Okay. I was just gonna mention at the end here. Check out Vulnerability Research Interest Group. They're not doing sort of exactly what I've been saying here, but they've been doing some really cool stuff with Chrome's V8 JavaScript engine, or that's what they did last semester. Sort of looking at end-day analysis, like I was talking about, and fuzzing, which is taking advantage of sort of large language models in sort of a feedback loop, as I was mentioning. And now I guess they're doing work with various memory allocators. I think they have that website at VRIDA group, but really I guess you should just talk to some of the people involved with VRIG, like Tanush or any of those people, I guess. Yeah. So does anyone have any questions or have anything you want me to go back to? I mean, that's hard to say because a lot of the stuff I did in the beginning was not like formally for CVEs. I was trying to run Wii games on my iPhone. So I sort of did stuff for that. I think that was like in early high school. Yeah, I mean, to some extent, some of this stuff can only be learned by sort of trying to find a project and sort of getting into the deep end and trying things, hopefully with someone to sort of to show you. But there are stuff like I mentioned, Pwn.college has some really good sort of introductory tutorials. They have video lessons and sort of sample things. I've heard some people say some really good things about that. There's also the aspect of you don't have to immediately find sort of impactful vulnerabilities. Sort of one of the first steps that I always do is just understanding how a system works. So if you can like have some basic programming knowledge in like Python or something, and you can explore sort of I don't know, APIs on iOS to do things at a fundamental level. For example, if you know anything about sort of like iOS programming, which, you know, if you're attacking a system, you have to know about the programming. I'm just using iOS as an example. You don't have to know iOS specifically. There are often like frameworks provided that give you like a nice, clean API to do things. But there's nothing actually preventing you from using lower level APIs. And so just understanding what those sort of helper frameworks are doing, especially like the open source ones, and going down a level often provides some nice insight. I don't know. That's sort of how I approach things. There are different approaches.
Thank you. Thank you, guys. That was a cool presentation.
Demos should be up right now.
Let me see. Demos should be up right now, guys. And yeah, we have our social hour and demo time, and then pizza will come out. Make sure you guys sign in because we will be checking.
my contribution to Social Hour. If you got a certification and you got the email from me, I will be doing as many as I can over in that corner. If you got a cert and you got an email from me, come over there. I'll do it today if you want. Also, if you know anyone else who did get it, let them know that I'll be here because there's no official like sign up for when it's done. But thank you.
Hello?
Awesome.
Cool. Awesome. Positive already.
Hi, guys. Hi. Hi, Brenner. Guys, it's time for research and news. Who's excited? Yeah. Okay, guys. If you're interested in presenting, there's like 2 meetings left after this one, so not much, and they kind of, I think, are mostly full. But if you're still presenting, if you want to, fill out this form and shoot me a DM. And as always, the blog is always open. You should post there if you want. There's some awesome prizes. Please sign in, which I'm sure you all have. Join the Discord. Check the calendar. You already know all this stuff. And of course, clap it up for the sponsors. Thank you. All right, some quick announcements. We have like 1 million WESIS things. There's the WESIS Cross Chapter CTF, March 28th and 29th. The WESIS Movie Night, and also if you need to scan these, I can go back. Just let me know. WESIS Movie Night, 28th as well at the Marshall, and the WESIS Ice Skating, March 21st at Tim Hortons Iceplex. Also, I just added this before I forgot. Slide roulette, guys, in a month about. You better start thinking about ideas. I'm going to post an official announcement this weekend. Start thinking. Also, election nominations. The form will close the 31st. Fill this out if you want to nominate someone, nominate yourself, whatever. You want to be e-board, fill this out. Now, some awesome news. I only did one today, guys, because I was very busy today and yesterday and the day before. Is it Crime Stoppers hacktivist leak? So essentially, there's a leak that has happened with this thing called P3, which is like this crime tipping platform, and it was referred to as Blue Leaks 2.0, and that's a reference to like Blue Leaks 1.0, which is a U.S. law enforcement leak that happened, which was much bigger. But essentially, this was a leak done by a hacktivist group to sort of just like demonstrate that none of this was actually anonymous, because there is like actual personal details in there. So as a hacktivist group does. Yeah, and also I found out about this thing called DDoS Secrets. It stands for Distributed Denial of Secret. Okay, yeah, whatever. But it's this website, and they actually just post leaks. Like, you can just go here and like look at leaks. There's like crazy stuff here. I had no idea about this. You can't see the leaks that were just posted for the Crime Stopper stuff, because I guess they didn't want to actually like leak it. You can like it's available for like security researchers and stuff. You have to fill some stuff out, but there is like actual leaks here, which is kind of crazy. Here's the one for the Blue Leaks 2.0. But I had no idea like that this website exists. But it's some pretty crazy stuff that when these leaks happen, like you can go and look at this stuff. So I didn't realize it was so like public and accessible. Those are my sources. And without further ado, we have some presentations. Owen presenting about automating the deployment of OKD, and some eBoard members talking about eBoard, especially with the election nominations coming up. Do you want me to pull it up online? Did you share it with me?
Huh? Sure what?
No. Did you share it? No. Who's snoring? You better quit that.
Snoring not allowed. No sleep.
You need to be awake for the most awesome research ever.
Facts.
Okay. Do you need like speaker notes or something?
No.
Okay.
I'm ready.
Let me get my charger before it activates.
Hello. Hello. Okay. Hi, my name is Owen. I automated the deployment of our club's OKD cluster, so I'm going to talk about it. All right. So Who am I? I am a second-year cybersecurity honors student. I am the tech lead for RITSEC. I'm also an ops member, and I'm the CTF infrastructure lead. I'm also a black belt and instructor for Ishinaru Karate. I really like badminton. I play a lot of card games. I hate Windows because Linux is better. And I have a MacBook because Windows really sucks. I play trombone, and I collect Club Penguin merchandise. Those are my puffles. I don't know what the pink one's name is, but I own all those. I have a lot of other stuff too, but those are the puffles. I like them. All right, so what is OKD? It doesn't stand for anything, even though I think that's a pretty good acronym for it, but it is an open source upstream version of Red Hat's OpenShift, which is a Kubernetes cluster. If you don't know what a Kubernetes cluster is a set of nodes. They work together to enable easier deployment, scaling, and management of containerized applications. So containers, if you ever worked with Docker, Kubernetes uses Docker to run a bunch of containers. It just makes it easier to manage them, deploy them, everything that has to do with that. It's across multiple machines, so it's a big cluster. It's really used for more production level environments, but we do have one for the club. It consists of master nodes, which is the control plane that manages the actual cluster and how everything's deployed, and the work nodes are what actually hosts the containers. So why use OKD? Probably shouldn't. It's a lot harder than a regular Kubernetes cluster to set up, but it does have its advantages. It's open source. It has built-in CI/CD pipelines. It has better default security. It has role-based access control, so easier to use user management, better security, but that also makes it more complicated to deal with. And it has a nice little web console that no one really uses that much anyways. But it is what we use. I don't know why we use it. That's what we have, though. So why automate it? Specifically automate the deployment of it. Well, it's a big learning curve to deploy it. There's a lot of steps. If something goes wrong and we lose it, which did happen not that long ago, we can bring it back up a lot faster if we have an automated way to deploy it. And it was also, for me, a good way to learn about Kubernetes, and as well as the tools I use to automate it, Terraform, Ansible, which most of what I use. And it was originally part of a mentorship I did with Maxim, who's a senior ops member, but it kind of turned into just my own thing because he's kind of busy. So most of it was just me doing that. And also, this is one page of documentation for the bare metal deployment of OKD, which is what I use for the automation. This one page is that many words and characters. I did not read it all, but yeah, it's a little complicated. So that is why it's easier to have it automated. So let's get into automating it. Part one is HA proxy. This is the infrastructure for our OKD cluster. Right there, the proxy node, that is HA proxy. That is the proxy that we use. I'll go into that in a second. We have 3 master nodes and 2 worker nodes for our cluster. So again, the master nodes are the control plane. Worker nodes are what actually host the containers. The bootstrap is just used to initialize the cluster. It's not actually part of it. So that is the infrastructure that we have for our cluster. That is the infrastructure that I have to set up, and that's what I automated the deployment of. So HA proxy is a load balancer and reverse proxy. This allows us to send traffic all directly to HA proxy. That is where we put the public IP address. And that way, it'll distribute all of that traffic into the cluster without sending everything to one node. So this helps us keep everything balanced, doesn't overwhelm any single node, and it's also a good way to control having different domains for different applications within the cluster. So very convenient. HA proxy is used for a lot of stuff. OKD is one of them. It is the main proxy used for OKD is what we use. So first off, there you go. The Terraform for HA proxy. This was Terraform to set up the entire network. We deployed it in OpenStack, but we used the bare metal deployment for it. We just used our OpenStack that we have as the means to do it. So for the networking side of things, we need a network for it, a subnet. So that's the OKD4net subnet, a router that routes everything for that network. This connects to the external network that we have on the stack, RIT-WAN. And then it needs ports for the router, a port for HA proxy, and a port for each of the nodes. And then HA proxy itself needs its own security group. It requires ingress TCP on all ports for SSH, and then ICMP. And it also needed for OKD, I think it was like 6443 and 22643 and a couple other random ports that are there. Needs a floating IP. That's where all the traffic is sent to. And actually, we ended up needing 2 floating IPs for the deployment, but only 1 IP after it's deployed. I don't know why, but. And then the HA proxy itself It just uses an Ubuntu image, big volume, nothing too crazy about that. So wrote Terraform for that. Terraform, if you don't know what it is infrastructure as code. It lets you kind of code the infrastructure itself. So I used the OpenStack Cloudflare providers. We also had to write, I didn't include it in the last slide, but there's Cloudflare Terraform for the DNS that we required for the cluster, because it does have certain DNS specifications that it requires. So these are all the files I wrote. Everything, this is on the HA proxy side of the Terraform. So this is like half the Terraform. That's just an example of what a resource looks like. That is how you define something in Terraform. So right there, that's me defining the router. Relatively simple. Some of it gets more complicated. Not too crazy though. But that's what all this is for HA proxy and the networking for OKD. And then there's the Ansible. This is deploying services and programs onto the actual infrastructure after it's created. So we run this after the Terraform. Once the HA proxy VM is started, the main things this does, it installs HA proxy, the actual service, applies the config file. We have a couple different config files. It changes throughout the deployment. This applies the initial one. Create an NFS directory. This share is used as the image registry for the cluster. So if you know like Docker Hub is an image registry where you can pull images off of, our cluster has its own image registry, so you can save images to it, pull directly from that image registry, which is useful. Then had to set up Nginx because I had to host the Bootstrap ignition file, which I'll get into later, and then install the actual like OpenShift OKD packages that are needed to work with OKD. And from those, we get manifest files. These manifest files define the state of the cluster, and that is where this Ansible ends because we have to manually edit those manifests to be how we want. So after we edit those manifests, don't have to make too many changes to them, that defines the cluster. We run the second part of Ansible. We take those manifest files, put it back in. They generate what are called ignition files. This is like, if you ever worked with butane, is what those ignition files are. They kind of define the actual VMs that are being made, because it is not like Ubuntu where it's a preset OS kind of like that. I want to say it's just core OS. So it was very like bare bones and used the ignition files to actually instantiate the VMs. So it makes those ignition files, sends them back, and it hosts the Bootstrap ignition file because it is too big for the Bootstrap node. It can't be directly put into it, so it hosts it on an Nginx server so it can be downloaded statically from there. So that is the second part of the Ansible 4 HA proxy. And now the second part, which is the actual cluster. This is deprecated because we actually ended up switching how this works later on. But originally, we deployed OKD using bare metal. That was all that big documentation I showed earlier. That is, if you're deploying OKD basically right on hardware, that's what that is for. We were not doing it right on hardware. We deployed it on OpenStack, but we pretended like it was bare metal, which is kind of weird, and don't know why we did that. That's how it's been done in the past, so that's how I did it. We ended up changing that later on. So now it has an OpenStack provider to do it, not automatically, but within OpenStack, it'll do a lot of the resource creation by itself. So we switched to that, but this is the part of the automation that was originally written for the bare metal. So there's more Terraform. Now that we have the ignition files, we can't create the nodes until we have the ignition files. We got those from the Ansible in the last part. We use those ignition files now to create the nodes. This is a lot simpler Terraform. There's not too much. This is making the Bootstrap, master, and worker nodes from those ignition files, putting them on OpenStack. Bootstrap, again, is only for the initial deployment. After all of the, it's Fedora CoreOS, that's what we used for the image. After all of the other nodes are started, they all use the Bootstrap to start up. Once they're started, the Bootstrap node can be shut down. And then there's more Ansible. So this is after they've all started. It looked a lot nicer before, and by the time we had this working, this is some very scuffed Ansible that Stella and I wrote, and it's gross, but it works. So this is for after everything's set up. This just finishes setting up some things in the cluster. There's a cert manager, so it manages the cluster certifications so that you can use HTTPS. And there's also some other weird things in there, but yeah. And so wrapping this up, why we ended up switching to OpenStack is, again, we're already doing it on OpenStack, so we might as well. And OpenStack kind of not the most fun to work with, so letting it work with itself for the most part made it a lot easier. But it's still confusing, so a lot of the OpenStack stuff was done by Stella, so I appreciate that. And then lastly, what is next for OKD? We use OKD to maintain all the infrastructure for the RITSEC CTF. So currently I'm deploying all of the info on that. That is in a couple weeks, so make sure you sign up for that. If you're writing challenges, get those in to me, please, because I need to deploy them. And then in the future, hopefully this summer or next year, we are going to be moving most likely more RITSEC services to OKD. So that's like the resume review services and like that. That'll be hosted on OKD because it makes it a little bit easier. And we might change how it's deployed after the stack is wiped this summer. We'll see. But it's also a goal to make it open to more club members if you want to use it. Currently, it's not open to everyone, but after the stack wipe, that will be something that we work on. But if you have a reason to use a Kubernetes cluster and you need one, let me know and I can get you set up with it. It's not that tough. All right, and that is all. Any questions? Cool. All right. Thank you all.
Hello. Okay, so wait, nope. Okay. Yay. We could just use both of these. It's not really my problem. Bah. Wait.
Alright, we'll sound better.
Me?
Hello.
Okay, we should probably start now.
All right.
Honestly.
Hi guys.
Stop touching me. my god. Hi, everyone.
All right, we're gonna be talking about What? We're gonna be talking about e-board,
More
sort of
like
the positions.
I'm bored.
Shut up. Okay, what is e-board? Many of you probably know what e-board is. Do you though? Pretty much, we're just like the people that run the club. No duh, but also like public figures, sort of like representing the club, talking for people, just doing everything in relation to management. And also, why is e-board? This is like, I was going to put something insightful here last night, and I totally forgot what I was going to write. But pretty much, like, there's a ton of stuff that happens behind the scenes that we all have to manage. And, like, there's tons of different roles, like mentorships, research, managing IGs, a lot of stuff which, like, you don't see. And that's kind of, like, our sole duty. Oh, and we stopped the club by getting hit by a meteor. And there's a picture of a meteor right there hitting the GCI.
This is true.
Okay. Quick overview of the roles. I sort of like put them into 3 buckets. I don't know why I put managerial. I don't know if that's really the right term, but they're sort of just like the heads of general meeting, which is like head of education, head of research, and then the tech lead. They're kind of the ones there for the meeting. The competition architects, who are like the, I don't know, more technical. Well, there's some other technical roles as well, but the ones who manage the competitions and put those like specific events together. And then there's kind of just like everyone else, which is like vice president, president, treasurer, like the big 3 that do a lot of work. The PR, director of PR, ops lead, and secretary, which sort of like have their own stuff that they manage. So president.
All right. Hey, everybody. I'm Dan. I'm the president of the club. Hi, if I'm meeting you the first time. So primarily what I do is I have a lot of responsibilities in making sure that the club does everything that we're supposed to, and we follow a lot of the guidelines that we're supposed to. So in order to do that, I help run all of the e-board meetings. I am involved in a lot of the planning for any extra events that we're doing, like the certification program, if any of you are doing that. So really those larger initiatives that are changing from year to year are kind of spearheaded by the president. And then on top of that, like organizing meetings with, say, like WESIS, for example, I meet with the assistant dean of the college, Lauren Shields, about once every other month to talk about the direction of the club and how Golisano can help us. And then I also meet every single week with our faculty or our department advisors, Britt Stanford and Lynn Wildman. Then on top of that, there's one more thing that I wanted to say. Yeah, I don't know. I guess I forget. Whatever. If you have any questions about like what the president does and what I do on a day-to-day, I know you see me, but you probably won't see me, doing a lot of things behind the scenes if you just show up to like our general meetings and the club room and whatnot. But come and talk to me if you're interested, for sure. Oh, I remember the one thing that I wanted to mention. Also, I help with the director of public relations for any event that we put on together. So our career fair eve events are an example of that. And over the summer, I spent a lot of time working with our director of PR in order to bring in new sponsors. So new sponsors like Travelers, Lockheed Martin, American Express, Magnet Forensics, those kind of things. I was meeting over the summer with all of those companies to get them to help us out. So yeah, let me know if you have any other questions later on. All right, Vice President. Hey, raise your hand if you don't know who our Vice President is. All right, only 3 hands, that's good. Vice President is David Gerard. Pretty much what the Vice President does is they're responsible for managing the e-board as well, but on a more personal level. So generally, they'll have one-on-one meetings if the members of e-board think that it's useful. Then the Vice President also manages the assistant board, or A board. So that's like our social media lead, our junior tech lead, junior ops lead, and social events lead. So he's responsible for coordinating all of those. And then I would say the biggest responsibility for the vice president is the like inter-department, inter-RIT communication. So he's there with me when we meet with the department every single week. He's there when we need something from like GCCIS IT, like if we need tables or access to extra computers. He's the person that goes out and does that and that sort of thing. So relationships within the college for the vice president are extremely important. And again, if you have any more questions about like what the vice president does and that sort of thing, I would say talk to David. All right. Do you want me to talk about treasurer?
I mean, we have a treasurer right there in the back who could come up and talk about it.
Alex, you want to talk about?
Alex, the last treasurer.
Here's our treasurer, guys.
Alex is.
No, don't clap for him. Just look at him.
Yeah, just look at him. Alex is our kind of treasurer now. He's really deep into the process of transitioning all of his responsibilities to Jake McChevitz. So if you want to ask any other questions about what it's like being treasurer, ask Alex. Any questions about purchasing, go to Jake.
Yeah. Yeah, so I don't know. There's not much to it. You deal with money, and that's a lot. He's laughing in the back. That's Jake, by the way. He doesn't get to stand up here until next year. No, I think, like, in all honesty, it's a good role to be in if you want to learn everything about club very fast, because everyone typically asks you for money. Whether it's being involved in competitions, just being supportive to your CAs, just like assessing what the needs are of the club, you kind of get a lot of control over what the balance is. You can set some direction, but it's very good to take in advice from the rest of your e-board. It helps make sure that you're making the right decisions, or the best ones that you can, so you don't like leave school thinking like you messed up. But
Talk about your policies, all of the policies that you have.
yeah, so policy-wise, you deal with like a lot of RIT. You realize how much bureaucracy there is, and when people say that you want to go into the government field, you start to realize if this is just the half of it, holy. A lot of the time I'm working with Britt Stanford out of the front office. They're really good about being that middle boundary. Whenever we're not getting stuff that we want, Britt does a very good job of making sure like people are on topic, or you know who to reach out to as like that next step. Yeah. Anytime that you fill out a tax form, that's us. That's a lot of what we deal with, is yelling at people for paying tax because we're tax exempt.
And a note on that, just like in general for the club, we are a tax-exempt organization, 501c3 organization through RIT. So RIT is technically the 501c3 organization, and we get tax exemption because we are a body of RIT. So that means that anytime we go for purchasing and we get charged tax, that's really bad, and one of our treasurers has to go to whatever business that purchase was made and beg them to take the tax off. That this is, as you can tell by Alex's reaction, something that he has done many times. So if you ever find yourself in the position where you need to purchase something with a club card, please, please, please make sure that there's no tax on it. Yeah, there's treasurer. Thank you, Alex. All right, Director of Public Relations. So Director of PR is responsible. Their main thing is communicating with our sponsors and finding new sponsors in order to, bankroll the club. Because, as you may have guessed, a lot of the stuff that we do for like all of you and all of us, it is not cheap. So, paying for meals for 150 people at every competition that we run, that gets very expensive. Putting on a certification program to pay for thousands of dollars of certification exams for all of our students, that gets expensive. So those sorts of things are it's really the job of the director of PR in order to convey the value that a company will get out of giving our organization money. And sometimes that's not exactly trivial, but you know, that's what the job is for. They also, just on here, they facilitate Career Fair Eve. They do the sponsor newsletter. They spend a lot of time on LinkedIn, naturally, and talk with the social media lead. So the Director of Public Relations and the Vice President are actually both responsible for the social media head. The way that it generally works out is the Vice President provides any support for the social media head, and then the Director of Public Relations will help with the content that is posted. That's everything that the Director of PR does. So that is the person you have to thank for having a bunch of companies come in person to our Career Fair Eve. And a note on that, we didn't have as many companies as were supposed to come because of that really, really large snowstorm that week. Unfortunate. All right. You want ops?
Sure, I'll talk about it. You've been talking a lot. Okay, ops lead. Do you guys know who the ops lead is? Raise your hand if you know who the ops lead is. Okay, not that many people. Some people. Guys, it's John Arundel.
Not enough people know who
Not enough
technically
people.
is.
This guy, he does like everything. John Arundel, is the one who keeps the stack up with the rest of ops. They put in a lot of work. Thank you, Lucas.
Thank you, Lucas Peters.
Thank you. A lot of work that you don't see and probably don't realize. For all the competitions, there's tons of stuff with maintaining the stack. There's a ton of work. Ops lead, they sort of manage recruitment, like everything that ops does, the direction that they go in. Like purchasing, there's a lot of stuff that goes on with like all the purchases that they need to make and working with the treasurer to figure all of that out. Running ops IG, training the junior ops lead as well and getting them ready to become the ops lead. It's a ton of work. I can't speak to everything that John does because I'm not him, I don't know, but I can tell you it's a lot of work, a lot of very technical work. It's probably one of the most technical positions on eBoard. But if you're interested in IT, like server administration, all that kind of stuff, then you should consider joining ops.
Yeah. And so, just one note on that. Purchasing is a very, very difficult thing for the ops lead and treasurer to do, because not many of you will probably know this, but every time we purchase something, especially if it exceeds a certain threshold of money, we have to get 3 quotes from 3 different vendors for each of them. And even if we know that one quote is going to be the cheapest, we still have to go out to 2 other places to get 2 more quotes. And then you end up in situations like this email that I attached. This was from a inside sales account manager. Hi, John. I don't work with students. Please forward this to the department head. And when you're in the position of it's your responsibility to get this done, and you're putting in all of this effort, that's a very frustrating thing to have. So just always be nice to our ops lead.
Oh, wait, is this me? Oh, shit.
No, he doesn't need that. He's got his own.
Yeah, I got my thing on my thing right now, man. All right, here we go. So this is the lit crazy position. This is low-key the best position in the world. Yeah. So basically, I do anything administrative or organizational. How do I put it? Yeah, lots of facilitating and communicating. So if you guys know, if you guys look at the weekly public notes that are posted every Thursday, I do that. If you watch the newsletters at all, I also do that. The weekly videos, I post those. So we're recording this and streaming this right now. I run the stream and I run posting the videos as well. RITSEC calendar, if you've ever looked at that and seen that something wasn't updated, that's my fault. I reserve rooms for events and stuff when I remember to do that. Like all the IGs, I communicate with them and make sure that they have a set time and location where they can have their meeting. So reserved at rt.edu is my best friend. If you become the secretary, you will more likely than not have to take the, EMS training, right? Yeah. quick little test. Don't put it off, or else Lynn Wildman will come talk to you and tell you to do it. And I do like other Discord mod related stuff. Like I have to approve every person who tries and joins the Discord if they don't have an associated RIT email. And I get like random people like, hey, my wife was an alumni 40 years ago. Can I be a member? I have to be like, sure. I don't know. Sure. Yeah. So I do cool stuff. It's pretty laid back, honestly. It's a great starting position. So if people are looking into being more involved with the club, I would recommend trying to apply for this, or run for the secretary position, because it's pretty fun, all things considered.
And throughout this presentation, we'll be saying, like, if you're interested or something like, or if you know somebody that's interested. And a lot of the reason that we're doing this presentation now is because nominations for all of these positions are open. And if you go into announcements, there's a Google form and that I announced, and it also says that you can nominate yourself. So if you think that you would be a good fit for any of these positions, don't be shy to nominate yourself, and especially if you know somebody else, feel free to nominate them.
Yes, we need e-board members. We need people who want to be e-board members. That's very important. So.
Okay, this is my counterpart, the head of education. There are two people who sort of run the general meeting. The head of education, obviously, running the education portion, and head of research running the research portion. The head of education does a lot of people management, so do I, but theirs is like focused on finding people to present the education for the meeting, which is typically like asking upperclassmen and more experienced members like who specialize in a topic to come and present, make the slides for all of that. And then also, they run the mentorship program, which is organizing like everyone who wants to be a mentor, and then figuring out mentorship groups, assigning all of those, checking in, making sure everything's going well with that. And they also do stuff with planning mentorship events, like mentorship hack nights, or what I forget exactly what we've had this year, but they'll do events for that. And so it's a lot of like just planning, working with people. And sort of like together we like manage the general meeting schedule of like when the general meetings are, what's going on that meeting, so all of that stuff. And then me, this is a dapper picture. Just a side note, is that a $300 medieval costume that I wish I bought? Maybe. Do I regret not purchasing it? Maybe. Yeah, I'm the head of research. Hi, I'm Hayden. My job is sort of, hi Dan. My job is managing the research portion of the meeting, which is what we're in right now. And so it's like getting people to like fill out the form to apply, seeing who's interested, reaching out to people. I also have done a lot of like trying to organize industry presentations, which is me emailing people, like whatever, getting ignored 100 times or ghosted, and occasionally getting an industry presentation to come in and present about whatever topic. We've had some interesting ones this year. And also secondary stuff. I do a lot with like managing the research inventory, research grants. There's a ton of stuff in HQ, which if you don't know is like a room in GSIS with crap everywhere. But there's a ton of our research stuff, competition stuff. We share it with Nexthop, so it's kind of messy. Also, like I manage the blog, which is pretty much mostly like VRig posting. Also, guys, surprise announcement, slide roulette. I said it earlier, I'm saying it again. Think about slide roulette. Come up with some funny ideas. If you don't know what slide roulette is, you essentially make a funny slide and you give it to someone without their prior knowledge, and they have to present it without seeing it beforehand. So you can target someone specific or just make a generic one. If you have questions, feel free to talk to me.
What do they get if they win the slide?
If you win slide roulette, your name will be forever engraved on the Slidely Cup. That is one of the highest renowned honors ever in RITSEC history, and has not totally been going only for a few years. Next up, tech lead. You just saw him, actually. Oh, okay. Previous tech lead.
We got a former tech lead right
I was
here.
the tech lead last year, so that gives me the authority to talk about tech lead. So, yeah, pretty much what the tech lead does is they make the demos. Enough said. But in all honesty, the tech lead has a job that has the opportunity to learn a ton, and because you have to learn every single topic for that education is going to be teaching, and you have to make effectively just like labs for people to apply those skills. So you have to get up to speed with the education topic. It always ends up being, a week or 2 weeks beforehand. So you effectively have to learn all of that information in a week, and then you have to come up with labs for people to actually apply those skills. And I personally think that the demos are like one of the really great things that we do for the general meeting, and people should just give them a try. So if you're interested in just like learning about, intro to cybersecurity, intro to Linux, Windows, getting more in depth for all of those things, the demos are a really good place to start that. And then at the end of the year, there are prizes to the 3 highest point earners, and the tech lead is able to determine what those 3 prizes are. Treasurer gives them a budget around like December time, and then purchases happen in like February or March normally, and they are presented during our last meeting, normally around the barbecue or with our elections. So yeah. All right, who wants?
Okay, I guess I can talk about it. Yeah, so the 3 CA, starting out with the IRSEC CA. So all of them, well, the ISTS and IRSEC CA have kind of similar jobs. IRSEC is sort of like, well, I wouldn't say like one's the lesser role, but IRSEC is sort of the smaller competition, and so theirs is much more like just working with black team, working with like RITSEC's red team, and sort of they sort of organize leads, they create the topology, they work on deadlines. It's a lot of managing like when things will get done and like making sure they get done. They also have to work with the treasurer for like managing all the food, the prizes, the clothing. Also, they have to reach out to a keynote, figure out the logo, all that stuff. So it's a lot of just like working with RITSEC students or club members and like everyone involved to sort of just like plan.
A note on some of these. So some of these positions don't have elections that are coming up. So if you're looking to nominate somebody for either ops lead, tech lead, treasurer, or CTFCA, those elections do not happen in the spring. So treasurer and CTFCA, those elections both happen in the fall, and then ops lead has a pipeline for junior ops lead, which is just normally somebody that is already on the operations team, and they get promoted to junior ops lead, and they learn from the operations lead until they become it the following year. Tech lead is something similar. There's an application generally in about October, and then the current tech lead decides who they would like to be the junior tech lead for the rest of the year to help them with demos, and then the following year that person takes over as tech lead and the process continues. So every other position there will be elections for in a few weeks. Make sure to nominate people.
All right, and the counterpart, the ISTSCA, it's a lot of the same stuff, but it's a sort of bigger competition because they're working with like colleges all across the U.S. It's not just RIT teams competing. The alumni is like RITSEC alumni and red teamers that like professionally red team who come and participate. Black team, it's sort of similar, but there are a few additional teams and topics, so it's sort of more to manage. They have a keynote speaker like IRSEC. There's like a few other minor details of like extra things that they do, but overall it's pretty similar, just another event. And
Yeah, I'll do this one. I already got my mic, bro.
my bad.
It's cool. Yeah. If you've ever competed in a CTF before, RITSEC has their own CTF. What is a CTF? It stands for Capture the Flag. So basically, you do like cool little challenges. Web, pwn, reversing, OSINT. What else is there? I don't know, a whole bunch of that's basically everything, a whole bunch of stuff in the CTF. So the CTFCA basically designs and does a lot of the organizational stuff for the CTF. The CTFCA isn't too hands-on. I think we should say that for like IRSEC and ISTSCA as well. While they are skilled technically, they are more managerial and can't be doing everything at the same time. That's what the leads are for. Okay, yeah, the RITSEC CTF is coming up soon, April 3rd, by the way. Please sign up as a team member or to be a challenge author, because we need challenges. So getting back into what the RITSEC CTA actually does more, as I was mentioning, they do most of the managerial stuff. They have to like reach out to sponsors if anyone wants to come and sponsor the CTF specifically. They have to choose prizes and things like that for the top 3 or top 5 placers, I think. Top 3? Yeah, top 3 placers. And, you know, they designed the entire theme of the CTF. So last year we had alien invasion. This year it's pirate themed. As you can see up there, you know, join the crew, do some cool plundering and things like that. And, you know, they ask people to write challenges. So if you want to find out a little bit more about what CTFs are like, go find the CTFCA, or, you know, come write a challenge or participate in the CTF. It's kind of fun.
And this CTF is fairly entry level, so I know I personally competed in it as a first year. So if you're interested in kind of getting your feet wet in what CTFs are like, start for this one. And a note on that, a lot of our prizes, so we have 2 sets of prizes. We have prizes for, you know, the wider like open audience, and then we also have prizes for just RIT competitors, and that is obviously a much smaller sample of people, so it's a lot easier to get those prizes. And the reason that is set up the way it is because sponsors give us money, and it is with the expectation that we are doing things to further the education of our students. And so that's why we can use sponsor money for those prizes, whereas the open prizes we have to find prizes from, you know, other CTF website subscriptions like Hack the Box, that sort of thing. And I think there's
one thing I'll add about the competitions, though, it wasn't really touched upon, but the RITSEC CTF isn't just like RITSEC. I mean, we just mentioned prize pools for other members who aren't at RITSEC, so it's like not only a national, but I think we get some like international competitors as well from different countries and things like that. And another differentiation between ISTS and IRSEC. IRSEC is all students here at RITSEC, or at least at RIT, and ISTS has different competitors from different universities. So we had like UCF, we had a couple Texas schools, Cornell. We had teams coming from everywhere to come compete. So that's what I'll add.
Yeah, and those competitions come up. The IRSEC competition is generally the first weekend in November, and applications for blue team open about a month and a half before that, and black team it opens about 2 months before that. So those are kind of the deadlines to be looking for next semester if you want to get involved. All right, so if none of these really interest you all that much, that's okay. There are other ways to get involved in leadership in the club. So there's interest group leads. So as all of you probably know, we have interest groups to kind of delve into each aspect of cybersecurity. And by showing up to all of those interest groups and learning from the current leads, maybe one day you will become the next lead. So for me, my first year, I showed up to wireless security very consistently, and the following year, the previous leads were they graduated at the same time. So my second year, I took over as one of the leads along with Jack Nardi, and that was a really, really good experience, and I think it prepared me well for leadership positions later on. Then we have our A board, so that's your social media lead and social events lead. Those applications come out at the beginning of every fall semester, and they serve for the entire year. And the names are pretty self-explanatory. So like social media lead, they handle our Instagram posts, LinkedIn, that sort of thing. And then social events plans, any fun social events that we have running, like the barbecue in Letchworth. And then finally, mentorship. Mentorship is probably one of the most like personal leadership opportunities that we have. So if you're like second, third, fourth year and you have some experience in a specific aspect of cybersecurity and you want to be able to teach other students what you know, a mentorship group is really, really good at making like a personal connection and drawing new members into the club. So if you have anything in mind that you would be interested in having a mentorship group over, please, please, please apply when applications come around in the fall. So, yeah. Anything else?
Question slide. But
Yeah.
Yeah.
If you have any questions, please come up to any e-board member about any position. It doesn't just have to be the position
Or
that
you can
we
ask
currently are. Huh?
I can ask right now.
Or yeah, you can ask right now.
Do we
Yeah,
have
that's why we're
any
here.
questions about RITSEC leadership
Probably
in
not,
general?
'cause it's boring.
Don't be shy.
Gonna start calling on people. No, I'm kidding.
Yes, Thomas.
Put the firewall up.
The firewall.
Put the firewall up.
One of our unsung jobs is to stop that from ever happening.
Yeah.
So you can rest assured that a meteor is never going to hit the GCI.
We've already
Thomas.
calibrated the ICBMs, so.
Yeah, we've figured out ways to make sure that doesn't happen. Any other questions?
Any serious questions?
Enough out of you. All right, cool. Well,
Thank you, everyone.
yeah, that's everything that we got for today.
Yeah.
Yeah. All
Let's-
right. Well, we'll see everybody next week. Thanks for coming in today.
Bruh. Okay, yeah, that's the end of the drummer meeting for today. Thank you everyone for coming in. If you opened one of the things on the ground to plug your laptops in, please make sure you close those. Yes, I do not want to have to hunt you down.
You better close it.
Yep. Thank you everyone.